This building right here, the actual delta of 25,000 was, it's kind of a, that was a tough number to really come up with because it was cheaper than the passive house. We saved 26,000 from the earth shelter, but what I had to do is I had to try to make some adjustment, like because it was a passive house building, we were getting some donations for being a first passive house public school project. So I had to try to make some calculations of what those donations were worth. It was a little tricky, but I thought it was about $50,000. So if I take the minus 26 plus the 25, that's why we ended up with that $25,000 investment. But the ROI there was 9% on that building. That was our predicted usage, and that was our actual usage year one. That's gross usage. I mean, right now this building's net positive, but this is not including any of the site generation, just actual usage. And it was really cool. We had at this point, I think, 16 months of energy data. And so what we said was, okay, well, the first, say, year of usage, maybe we didn't have, maybe things weren't fully operational, whatever. So we took in that 16 months, we said, what was the highest 12-month average that we could find in the 16? And we were within 100 kilowatt hours of our prediction. So, it's pretty much fun. And then this was the other piece, thermal comfort surveys. I don't know how many of you ever gotten that point in LEED for doing thermal comfort surveys, but we always go back and do them just because I'm interested, even though nobody ever asks us. I ask other people who have gotten the point and never have gone back and done them. But I like to do it because I like to see. But this is really cool. This is the only one I've ever seen where there was 0% dissatisfied. There were some neutrals and some satisfieds and no dissatisfieds. So pretty cool stuff. And the cost is 26,000 less than the earth shelter building with 25% higher energy savings. I'm not going to put a per square foot cost because this has got gray water recycling, rainwater recycling, green roof, permeable concrete, recycled material. I mean, it's got every bell and whistle you could throw into it, and 3 different types of PV systems, a wind system. So a square foot number on this really means nothing.
How much?
It was about $300 a square foot for the building. But that's with everything. That's with all those systems. $25,000 monitoring system, blah, 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 blah. I mean, lots and lots of stuff. So here's some other passive house heroes that I want to talk about. Tim McDonald down in Philly. He's got a company, Onion Flats. They do design and construction, and he also owns a modular company called Blocks, and a green roof company, and a solar company. And so here's Tim's project in Philly. I went up to Philly to visit Tim. I wanted to see it in real life as he was getting it. This was the week after he was, and this is the kind of architect I like, the one that wears a tool belt and a hammer and understands this stuff and can really draw stuff that can be built. That's the kind of architect that I am, and that's the guy I like. And there's the finished product, right? So a really nice triplex. They're doing some other projects now too, and this is amazing. 129 per square foot all in, 177 a foot for the mods only. And this is Tim's thing. 0 energy, 0 premium, 0 debate. Love it. He didn't even tell his clients he was doing passive house. He's just delivering a hell of a good building. Is Alan here? No. So Alan Gibson's from up in Maine. He's doing a co-housing project. We're also working on a co-housing project in Virginia that's going to be passive house. And we're shooting for a delivered cost of market rate, which is in our area about 125 bucks a foot. Alan in Maine was able to deliver for 135 bucks a foot. Belfast co-housing. That's a really good price in Maine, wherever, yes it is. This is the Unity College dorm that they built, I guess, a year ago or so. They're 207 a square foot, and that included their solar thermal system. Very competitive. Custom home that they did, including renewables, 176 bucks a foot. And this is like my super duper hero. I mean, when I first met this guy, I've been reading the stuff from Cold Climate Research Center. I don't know how many people have read the Cold Climate Research Center papers, but I kept seeing this weird name, Thorsten Schlupp. Never said it, I just read it. And then I met him for the first time a few years ago, and I was like, are you the Thorsten Schlupp? I know about. But this guy, I mean, way before he was doing Passive House, he was doing amazing things in Fairbanks. So we got, Passive House is minus 48 degrees, zero energy, okay? Net zero, $234 a square foot in Fairbanks. And this beast, he calls it, 9,000 square foot house, I think somewhere in there, or 7,000, I can't remember how big, it's huge. Same, he's working on this right now, there it is, this summer, being framed. This one, zero energy, $205 a foot. That's some pretty darn good news. I mean, this is some impressive stuff people are doing, right? So, that's the question, right? That's the next step. Okay, well, there's the good news. That's what we did. How did we do it, right? How can I repeat that success, right? That's the obvious question. So the first thing we got to do is look at, you know, what we've been doing for the last 100 years or 50 years at least. You know, we've been doing this type of delivery where the owner hires contractor, energy modeler, an architect, engineers, subcontractors, and of course, you know, team build is just no build, design, bid build. Right? Same structure, just no bid. And then of course you can have all these various interrelations and inter subcontracts, and people don't have to hire, the owner can hire the engineer, the CTHC, BI for the contractor, architect, subcontractor, the guy for the owner. And you end up with this octopus with all these arms, but there's no brain, right? There's like 8 different brains, right? So what I have done in our firm is I've been doing design build for 30 years. Right? So we're the architect, and we're the builder, we're the energy person. We're also, you know, the guy that goes and cleans the floors at night. So, you know, design build, I didn't, you know, I told folks, yeah, this was really the way to deliver this stuff, but the more I got into this, and I saw what other people were doing, and then when I started having calls from other people from around the country to come and help them do it, I realized just how good integrated delivery really is to deliver a project on budget. Because it only takes one of these people to put a kibosh on the whole deal. So, you know, this is your typical building project, right? You got all these chiefs, right? And everybody's got their own agenda, everybody's got their own interests, and everybody's kind of commanding their own troops, right? Well, we got to go from this to deliver a high-performance building in an efficient manner on an efficient budget. Like, do y'all know about the Bullitt Center out in Seattle, the Green Living Challenge big building that's just been built? Huge, beautiful building that's been built with a huge, beautiful budget. If you have more money than you care to think about and you can spend it on whatever, you can do anything you want, right? It's only limited by your money and your imagination. Most of us don't have that luxury. So this is where we usually start from, right? But we got to go from there to the hive mind. Right? We all got to work together. You know, when I go over here and I change this light bulb, that guy over there has got to know it, right? So if you're able to get the big picture and you're able to keep all that in mind and balance all those things, I mean, my electrical engineer can't decide that the lumens that I don't have a high enough light level at my desk level and replace my 28 watt T5s with 54 watt high outputs without telling me. Right? That's what they would normally do. They're going to sit in their little cubicle. They're going to run their point-to-point calculation. They're going to go, oh, that lighting level is too long. I'm going to just take that bulb out. I'll throw in a 32 watt. I'll throw in a 54 watt. No, I never even notice it. I mean, do I read the lighting schedule typically to know what wattage bulbs are going in those fluorescents? I see them on the plan. Yeah, they're fitting in my ceiling grid, but do I care? Well, I better care because it's going to affect my energy load. It's going to affect my heat load. Right? So, I mean, it's every little thing really, I mean, we're actually building, you know, the building as a system, the building as a holistic living entity, all that stuff that we learned, it's all true, especially when you're talking about high performance, right? When you're talking about standard construction, where you're just putting in huge mechanical systems and you don't really care about energy, big deal, you do whatever you want. But all of a sudden when you're talking about a building that's tuned, it's got to stay in tune, and you can't put it out of tune to start with. Right? And believe me, everybody here who's built knows that the guys in the field are the lowest common denominator, and there's plenty of stuff that changes between the drawing board and the field. And so that's where this type of delivery becomes really, really critical. And one proven example of this is design build, where you have all these different chiefs, all these different pieces that have to go into making the building, and that nexus, that little intersection, is the design builder, right? 1 point responsibility, right? One person to wag your finger at, one person to slap on the back. There's no passing the buck, right? As Kristen said, I don't know if Kristen's here, yesterday we were sitting around, and she goes, well, aren't you concerned about liability? Putting yourself, I was like, well, you know what? We never, until this year when we started, this is the first year that we've actually done architectural drawings that we didn't build. We've always designed what we built what we've designed, but that was it, except for on occasions we would build stuff for other people. But we never designed stuff that we didn't build. We would build other people's design, but we never designed stuff we didn't build. And so we finally got E&O insurance this year, because this is the first year we're actually designing something we're not building. My attitude about this for the last, since I've been doing it, is that it's all going to land on my shoulders anyway. What am I going to do? Sue myself? You know, I mean, what's the point of paying an insurance company? Because it's all going to be, you know, it's all just a cluster of suits that when it all gets down to it. So, you know, anyway. So, but this is the way to make sure that you're going to deliver an efficient passive house or high performance building, whether it's passive house or not. So the other reason that this is, you know, everybody's probably familiar with this curve. Like so your ability to impact your cost and function of a building is highest in the pre-design phase, and as it goes along, it gets lower and lower and lower. And of course, the cost of those design changes go up and up and up as you go farther along in the process, right? It's pretty common knowledge. And what we've been doing for the last 50 years is, well, I guess I didn't have it here, but we're establishing in design bid build, we're establishing our pricing here, like the worst possible time to establish pricing. So if I want to change anything, it's going to be really, really expensive, and it's going to be really, really minor, right? And in team build, you generally establish your pricing right in this area, somewhere 30 to 50% CEs typically. And you know, that's better than this, but it's not nearly as good as design build, where we are typically establishing a hard contract price in early phase of design development. Why? Because we control everything from day one. Because we know what's going to go into the building. We're able to get a hard price on the building early in the scheme, and we're able to say, well, what can we change to make it more efficient? And then we're able to see the process through all the way to the end so that things don't get lost between here and construction. Oh, there they are. Okay, there's a little arrow there. All right, so that's good news, right? So we have this huge opportunity to build these buildings, right? We can just go out now and start building some really cool high performance buildings, because we have everything it takes to save money and save energy, and we have no place to go but, right? Because this is great news, right? This stuff's cheap, it's affordable, it'll perform. I mean, what's the bad news, right?